Hello friend, myself Prof. HK. Last video we can discuss steady flow, flow line, streamline, flow tube, streamline, streamline or laminar flow, turbulent flow, critical velocity, Reynolds number, and very interesting property of a fluid is a viscosity. Then today's video we can discuss first one, Newton's law of viscosity. What is the statement of a Newton's law of viscosity? Statement here: for streamline flow, viscous force acting on any layer is directly proportional to first area of the layer. This area of layer denoted by A, and second velocity gradient, that is this become dv upon dx. Statement repeat again: for streamline flow, viscous force acting on any layer is directly proportional to area of layer and velocity gradient. Explanation here: let capital A be the area of layer, dv upon dx velocity gradient, and F be the viscous force. According to statement of Newton's law of viscosity, this viscous force directly proportional to A, this viscous force directly proportional to dv upon dx, combine these, F directly proportional to A into dv upon dx here. Dv upon dx. Then we can write here, combine F directly proportional to A into dv upon dx. Remove this proportionality sign. We can write here F is equal to eta into A into dv upon dx. Consider equation first, where eta be the proportionality constant is called coefficient of a viscosity. Then we can calculate coefficient of viscosity. It's given by here, eta is equal to F upon A into dv upon dx. dv upon dx. Eta is equal to F upon A into dv upon dx. This is a formula to calculate coefficient of a viscosity. Some notes prepare here. It is depend upon nature of liquid. The coefficient of viscosity depend upon nature of liquid. Then we can prepare the definition of coefficient of a viscosity. Definition: the coefficient of viscosity is defined as the viscous force per unit area per unit velocity gradient. Definition repeat again: the coefficient of viscosity is defined as the viscous force per unit area per unit velocity gradient. Then we can write in the formula, eta is equal to F upon A into dv upon dx. SI unit of coefficient of viscosity is Newton second per meter square, because here force measure in newtons, area meter square, and dv upon dx, the unit is seconds. CGS unit dyne second into centimeter square. It is also called pots. SI unit Newton Newton second per meter square. CGS unit dyne second per centimeter square. It is also called watts. Dimension here L raised to minus 1, M raised to 1, T raised to minus 1. The relation between SI unit and CGS unit of the coefficient of a viscosity. This become here 1 Newton second per meter square is equal to 10 poise. Then this become 1 decapoise. This is a very important relation. Note prepare here. If A is equal to 1, dV upon dx is equal to 1, then eta is equal to F. That is what coefficient of viscosity of liquid is equal to the viscous force. Next law is the Stokes law. Another law of a viscosity is a Stokes law. Statement: the viscous force, this viscous force, consider F suffix V acting on a small sphere falling through a viscous medium is directly proportional to the radius of the sphere small r, its velocity v through the fluid, and the coefficient of viscosity eta of the fluid. Statement: the viscous force F suffix V acting on a small sphere falling through a viscous medium is directly proportional to the radius of the sphere small r, its velocity v through the fluid, and the coefficient of viscosity eta of the fluid. Then we can write in mathematically F suffix V directly proportional to eta, directly proportional to r, directly proportional to v. Then we can write here F suffix V is equal to, remove this proportionality sign, we using some constant. F suffix V is equal to k into eta into rv. Here we can write F suffix V is equal to 6 pi eta rv. Consider equation first, where k is the constant of proportionality, numerically equal to the what k is numerically equal to the 6 pi, that is k is equal to 6 pi. Then we can write here F suffix V is equal to 6 pi eta into r into v. Consider equation number first. This equation first represents the expression for viscous force acting on a sphere object moving through a viscous medium. Note prepare here. The above formula can be derived using dimensional analysis. Some question asked on this topic. First question: state Stokes law. Then first question asked on this topic: state and explain Newton's law of viscosity. Next question: define coefficient of viscosity. State SI unit of a coefficient of a viscosity. Or another, find the relation between poise and the SI unit of a viscosity. This relation become 1 Newton second per meter square is equal to 10 poise is equal to 1 decapoise. Then we can discuss next very important point, terminal velocity. What do I mean by terminal velocity? Definition here: terminal velocity. Definition: the spherical body attain a constant velocity called as terminal velocity. The spherical body attain a constant velocity called as terminal velocity. Or definition prepare here: the constant maximum velocity acquired by body following through a viscous liquid is called terminal velocity. The constant maximum velocity acquired by body falling through a viscous liquid is called terminal velocity. See next diagram here. What do you mean by terminal velocity? Definition: here we can consider what is mean by terminal velocity. This is a sphere. This is a spherical body attain a constant velocity. This constant velocity is called as a terminal velocity, or the constant maximum velocity acquired by body falling through in a viscous liquid. In this liquid is called terminal velocity of that spherical body. Here we can derive equation for a terminal velocity. See this diagram, figure terminal velocity. When a spherical body fall through a viscous fluid, this is a spherical body fall through a viscous fluid, it experience viscous force. The motion of body is initially accelerate and velocity begin to increase here in this direction. Here light small r be the radius of spherical body, rho be the density of liquid falling under gravity, sigma be the density of medium when spherical body falling under the gravity, g acceleration due to gravity, and eta coefficient of a viscosity. See here in diagram. Here small r, okay. At terminal velocity of a body, total downward force is balanced by the total upward force due to upthrust and viscous force. This viscous force considered buoyant force. Then total upward force this is a total upward force. We can write here upthrust due to medium, this plus viscous force here. Okay, then we can write here total upward force is equal to viscous force plus upthrust due to medium. Here viscous force become, according to Stokes law, 6 pi eta v into r plus upthrust due to medium, this become 4 pi r cube into sigma into g here. Consider equation first here. Then total downward force, this become, see in this diagram, total downward force This total downward force Fg means what? Weight of this sphere here, that is W is equal to mg. This is a total downward force acting on a spherical body. Then we can calculate here. Total downward force acting on the spherical body. This is nothing but weight of the sphere. This weight of the sphere means what? Mass into acceleration due to gravity. But mass is equal to what? Volume into density. Then we can write here volume into density into acceleration due to gravity. Here reason here, mass is equal to volume into density. Then volume become the spherical body. We consider here this is a spherical body. Volume this become 4 by 3 pi r cube. Here density become rho and acceleration due to gravity is g. Then this become 4 by 3 pi r cube into rho into g. Consider equation second. When the sphere attains terminal velocity, the total downward force acting on the sphere is balanced by the total upward force acting on the sphere. When the sphere obtains terminal velocity, the total downward force is acting on the sphere is balanced by the total upward force acting on the sphere. Then we can write here both forces are balances here. We can write here total downward force is equal to total upward force. Consider equation third here. Put equation first and equation second. In equation third we get here a total downward force. This become 4 pi r cube into rho into g is equal to total upward force. This becomes 6 pi eta v into r plus 4 by 3 pi r cube into sigma into g. Rearranging above equation, we can write here combine this term this term 4 by 3 pi r cube rho into g, and this term we can given here 6 pi eta v into r 4 by 3 pi r cube into rho g. This term here plus here. Then rearranging this minus here 4 by 3 pi r cube rho into g minus 4 by 3 pi r cube sigma into g. Here 4 by 3 is a constant, pi also constant, r cube also constant, and g also constant. Take outside the bracket here. Then we can write here 6 pi eta into v into r is equal to 4 by 3 pi r cube into g. Remaining what? Rho minus sigma. We find terminal velocity of the sphere. Then we can write here terminal velocity of the sphere is v. Then v is equal to 4 by 3 into pi r cube into rho minus sigma into g upon this become 6 pi eta into r. Here pi gets cancelled, here r 1 r gets cancelled, remaining what? 2 here. Then here next step we can write here V is equal to 4 into r square into rho minus sigma into g upon 3 into 6 into eta. Here take adjustment sum here 2, here 3, then we can write here V is equal to 2 by 9, 3 into 3 this become 9, 2 by 9 into r square into rho minus sigma into g upon eta. Consider equation 4th here. This equation V is equal to 2 by 9 into r square into rho minus sigma into g upon eta. Consider equation 4. This is the expression for terminal velocity of the sphere. Some question asked on this topic. This is a very important point. Define terminal velocity. Obtain an expression for terminal velocity of a small sphere falling under gravity through a viscous fluid. Repeat again this question. Define terminal velocity. Obtain an expression for the terminal velocity of a small sphere following under gravity through a viscous force. Some notes prepare here. First note, the velocity with which an object can move through a viscous fluid is always less than or equal to the terminal velocity in that fluid for that object. And next one, for air medium sigma is neglected, then we know that equation for what is the equation of terminal velocity. This become V is equal to 2 by 9 r square into rho minus sigma into g upon eta. Here sigma is neglected, then we can write here V is equal to 2 r square into rho into g upon 9 into eta. This is a required equation for air medium. In this way we can complete very important concept in viscosity. First one, Newton's law of viscosity, then next one, coefficient of viscosity, then Stokes law, and another is a terminal velocity and derive its equation for the terminal velocity. Today we stop here.